Okay, so um, I will be doing videos Fridays for the end of this, and this one we're gonna focus on review visits or exam that's coming. Your exam will be online, proctor that will built into testing software, and it'll be a lot like the other tests that you took in how you take. Um, I understand that with the tragedy that happened on campus, that we're all recovering from that and might need flexibility in dates. And for any of the homework, turn it in whenever you need to. Into the you're you're missing something, um, do it when you can and turn it in. And if you need time to prep for exams, I can be flexible with those due dates as well. Anything you need, um, to do the best you can in this. Um, so I am going to pull up. I just published. I it's called Quiz 9, and it says Exam 2 Practice. This is your study guide for this exam. Um, it'll look very similar to the exam that you'll take, and we'll we'll go from there. So let's first question. So oh, by the way, the quiz, the practice exam quiz, it is for points, so it does affect your grade, but you can take it as many times as you need to until it closes. So it'll keep the highest grade that you have, but it'll let you take it as many times as you. And if you score lower on a subsequent take, it'll keep the higher score. So, good luck. Question one is we want to simplify this expression. Sine arc tangent of um, so everyone will have their own a value and their own b. The ones that I were given were 0 and 4, which kind of silly. I should go back and make it so that a never 0 question. That trivializes. So I'll try and I'll do it with this a value, and I'll do it with another a value, just so that we don't have actually. Yeah, I'll do it as written first, and then I will change the a value and do it, and then I'm going to go and reprogram the test to make sure that a is never. Anyway, um, this is the first step, and then after we simplify this, we're going to have that written down and submit that as part of later question. It says submit the simplified expression in the file upload question. That's the last question of the test or the practice quiz, whichever one. And then it says evaluate this at x equals, and your x value will be unique to you. Mine is x minus 3, and then type that in and submit the answer to that. So with this type of question, have an arc trig function inside of a sine, or inside of a trig function. The way that we want to do this is we want to make a triangle. Angle, we will mark theta. And I want to make it so that the tangent of this triangle is that fraction. And unfortunately, that fraction is going to be 0. So I will get 0 x for the opposite and 4 for the adjacent tangent, the opposite over the adjacent. And if you have a different trig function and different arc trig function, or you just label the triangle according to your trig function. The sign of this is going to be the opposite divided by the hypotenuse. So that'll be the opposite, which is 0, divided by the hypotenuse. We would calculate using Pythagorean. But because the numerator of our fraction is, this simplifies to be the sine of 0. Sine of 0 equals 0. I plug in x equals -3, and I still get 0. That's the answer to that question. Let's redo this with something that. So let's just do the same question, but instead we're going to have a equal. Leave everything else. That'll be less. Copy everything. Okay. So with this, now when we label our triangle, we're trying to find the sine of the arc of 1 times x over 4. Do that, we will label our triangle so that the tangent of this triangle is equal to x over 4. And we could label this in so many different ways, but x and 4 like that are probably because the tangent opposite over the adjacent. So this way I have x divided by 4 tangent. Get that? I could have labeled it as like maybe x over 4 and 1. X over 4 divided by 1 is still x over 4. Or I could have labeled it like 2x 8, and that'll still divide to give me x over 4. But we don't need to complicate anything. Just suffice it to say, there are several things we have labeled. And any one of them will get us the same answer. Perfectly fine. So if you did it this way and friend did it this way, you're fine. Okay. So with that, I now need to find the sine of this triangle. And to do that, I'll use the Pythagorean theorem. Get 4 squared plus x squared equals hypotenuse squared. I take the square roots. Square root of x squared plus 6. My sine is now equal to the opposite divided by the hypotenuse. So this is what will be written down and turned in the file upload question. What you will type in for question 1 is we will take this number and plug it in, giving us -3 over the square root of -3 squared plus 6. -3 squared is 9. 9 plus 6 is 5. Get -3 over 5. And the square root of 25 is 5. -3 fifths. That is going to be our answer. That's what we're going to type into, well, for the Desmos question, or for the Canvas question, we're expected to type in a decimal. So you're going to type it in as -0.. That will be your answer that you type in for question practice test. Let's look at question. We want to solve the equation a tangent squared x plus tangent, not tangent, just tangent of x. And for me, my numbers are a equals 9, this becomes -9 tangent squared x plus tangent x. To solve this, I'm going to factor my equation, factor the tangent out, get -9 of x plus 1, 0. And then I know that if I have two numbers that multiply together to give 0, one of them had to be either tangent of x, 0, or -9 tangent of x plus 1 equals. Now, this question, I'm asking you to find the answer that is between okay, so this one we're going to get multiple. This equation solves as x tangent 0, x equals 0. There are multiple solutions because tangent is periodic. Everywhere where the y coordinate is 0 is going to be a solution. But we're just going to be worried about that are negative pi and pi. So this is one here is at x equals. That is outside of the bound. Okay, so this is one solution. Over here we get, let's subtract 9 tangent to the other side. X 1 tangent of x 1/9, and we're going to x equals arc tangent of 1/9. Now, we use a calculator. Here to use a calculator on this test. My calculator for the divided by arc button. So here's how to check to see the calculator. So if I type in sine of 90, if I get 1, then I'm in. If I don't get 1, I'm in radians. And I know this button says rad for radians here. Some calculators, it displays what your calculator is current. Some calculators, this is the button you press to change radians. So you never want to just trust that. You want to test your calculator, make sure that this one apparently works where it's showing me that it is currently radians. I click on this at radian degrees, back to radian. Anyway, so oh yeah, I need to clear it because I'm going to do 1 divided by 9, and then I'm going to trigonometry, second, me. That's in radians, so that's rounded to 2 decimal places. 0.11. That's what I'm going to type in for that question. question. I'm just going to plug the numbers in that I'm given. Get 7 of pi over 9x plus 8. We want to solve this for. We're just going to take, like, because these are periodic functions, we're just going to take the answers that are within um, the region that the arctrig function. So that's going to depend on which function we're using, but like for instance, sine and tangent invert between negative pi over 2, pi over 2. So we're going to use for tangent, sine, values that lie between. Whereas for cosine and secant, those functions in 0, pi, solutions. In case we act on the bound. So we're going to solve this. First thing to do is divide by 7. X3 equals 7. Take the arctangent sides. Arc of negative 8, 7. Add subtract 3 from the sides. 10 by x plus the arctangent of negative 7. And then I multiplied by the on both sides. Those can x equals negative 3 plus arc negative 8, 7 times 9 over that into our calculator. Negative 8 divided by 7. Negative 8 divided by 7. I want to trig function. I'll then subtract this and divide by over here x equals decimal negative 1 0. That's the answer I would type. Or have triangle with sides 10, 13, 7. I'm asking area of triangle. Heron's law. Heron's law says that the area of a triangle, we're going to use square root of semi-perimeter, I will define later, times semi-perimeter minus a, b times the semi-perimeter is just you take the perimeter all the way around the triangle and we cut it in half. this is A, B, and C, going to be equal to A plus B over 2. 7 plus 13 is 20. 20 plus 10 is 30. Semi-perimeter is 15 minus 7 is 8. 15 minus 10 is 5. Minus 32. So now I have a calculator. Plug this in. But what I could also do is I could have 3 times 5 squared. 5 there. Squared. 5 times square root of 3. Exact answer. You type that into a calculator, get approximate. 3 is about 1. About calculate. Square root. That's the square root of 3. It's 34. 5. Have a triangle. Hold side A 9, side B. Angle C. Want to solve for. So, our two tools will be law of cosines, squared equals squared minus of angle, law of sine. Sine of A divided by B of C. We're on our triangle, like both of these have the property that big letters were angles, and the little letters were sides across from A being area, because we already used A in both its capital forms. So, and K is a pretty. So we're just solving for C, but we could solve for any of these. Let's draw a triangle. If C is 50, I'm going to assume that's not the, but still going to draw the triangle. Call this 50. This is the side we're looking for. One of the sides is 9, the other side 8. And we can law of cosines. Side we're looking for squared equals A squared is 1. Squared is 64 times 9 cosine of 3. That means squared equals 81 plus 4 is 140. 140 cosine take the square root of that. Square root of 5 minus 1, 4. About our calculator. First, we want to type in. First, we want to check that button, and that is in. Now we type in 50. Type in cosine. That's cosine. Multiply that by 1/4. This. Then we are going to the negative. Add it to this. Then we need the root. That gives us this here. We're told round to 2 decimal. Round to 2 decimal. So that's going to be 7.4. What we'll type in. Six. Almost. Verse 6 says, have play equal 3, big A 40, big B 34. We're trying to find little b. So this one, since we know a pair of angle and its opposite side, and the thing we're looking for is in a pair with another angle we know, we can set up that sine of 40 degrees over 3 equals sine of 34 degrees over b. We solve this for b. Fractional. Sine of 40 b over sine of 34. We multiply both sides. 4 cancels on the left, goes into the right. This is what we would like. This calculator is just not designed well for this type of. Type in 40 and sine button. Get this. I'm going to keep calculator. For round. There's more precision than, but it will. Okay, now we also that's got to sign it. So that was sine of 4. That's the one. I've now taken sine of 34 degrees. I'm going to multiply that by 3. That gives me the numerator, and then I'm going to divide by the denominator. 4, 7. Two point one. There is. Okay. Now, question 7 on this are some trig identities to prove. I have a few of them here because this is the practice quiz. I probably single one actual, but I might have, or I might. Anyway, we have the last question is proving some trig identity. This is the cubed. So all we're trying to do, make sure that the left side and the right side are, do this via figuring other trig identity. No. Pythagorean. I'll do another. Actually, I have a video. But I rather than there's a video on there are videos on the trig review. With this, I see a bunch of trig functions applied together. That makes me, if I convert to sines and cosines, I probably get some cancellation. I'll try that. Tangent is sine over sine, so turn tangent sine cube. Cosec 1 over sine, so 1 over sine squared. Cosine over sine squared. Have times cosine x times sine left hand side. That side. Left hand side equals. Then I go and I say, okay, well, I have 4 sines and they cancel. And I have 3 cosines. Well, so 1 over 1, and that is the right hand side of the identity. So I am that proves. Here is sine of x over 1 plus squared. I want to prove this one, and this one I see this is a double. So I know my double angle identity. I know that sine of 2x sine x x. If I don't know my double angle identity, I know that sine of x sine of plus x. And if I know my angle sum identities, this is sine of the first angle times second angle plus sine of the second angle sine of the first angle, which still adds up to sine x x. If I don't know my angle sum identities, then practice test. And I'm going to upload a video. That would be. Have this. So the left hand side is equal to this by the doubling. 2 sine x. I'm trying to make it like that. So if I want to get top, I might decide to this by cosine x sine. Top and bottom of a fraction. Fraction is 1, multiplying by 1 values. To do that, I get 2 sine x times squared equal to times 1 over all I'm doing is I'm finding this fraction. Now, I have first Pythagorean identity, one that I gave you. Squared 1. But if I divide everything cosine squared 1 equals x. Secant squared x, get 2 tan x over this is that, get squared x 1 and done because that's last this one an triple angle identity memorize, but it exists. On the other hand, if you don't have it memorized, hello, can you like it's I have to talk a little bit louder than what so I'm going to talk a little bit. I haven't been talking too quietly for so left hand side of this split into sine of x, which is angle sum sine of x plus sine of cosine x. And then by the double angle formula, get sine of x, sine of double angle. And over here, like we want a negative sign. Well, it's sine of x times sine squared x minus sine squared of x. That's the double angle. That's one of the double angle formulas for sine. Let's try this one. The other ones you get by doing. So we get 2 sine squared x plus sine of x minus sine x because that combines to get 3 sine of x x minus x. I want a sign here. I want a 3 times. And then we need to have a bunch of. I think that we're Pythagorean x plus cosine squared x. 1. I'm going to solve this minus x. I'm going to plug that in here. 3 sine of x times 1 minus sine squared minus x. Then I'm going to have control. So I do this at sine of x minus x sine x sine times, and that gives us 3 sine of x sine x term with. This is left hand side, or the right hand side of the equation. Those are all of the questions on the practice test. The real test will look a lot like this, but the proof questions, identity proof questions, hope that this is useful. I hope the study guide that I is also. Test is scheduled to go next week. If you need more time than that, then let me know and I can send the deadline on that. Best of luck to all of you. I'll do another video on Friday next week. And great weekend.